And then the final thing is to sort of don't just follow the trend. So you may have heard me say that it's good to think in terms of the physics approach of first principles, which is rather than reasoning by analogy, you boil things down to the most fundamental truths you can imagine, and you reason up from there. And this is a good way to figure out if something really makes sense or if it's just what everybody else is doing. It's hard to think that way. You can't think that way about everything. It takes a lot of effort. But if you're trying to do something new, it's the best way to think. And that framework was developed by physicists to figure out counterintuitive things like quantum mechanics. So it's really a powerful method.
My point is, though, does this really matter? I mean, you could look at this and say, well, at least science, particle physics was on the front page. But I think it does matter. You see, the point is that we live in a society, as the great physicist and communicator Carl Sagan always emphasized, a society that is entirely based on science. It is based on technology and engineering. All the great important decisions that our democracy will be forced to take in the next decades and onwards into the 21st century are based on science. They're based on the scientific method. They're based on an understanding of what reason and reaching conclusions based on evidence is. And if the presentation of science is a Frankenstein presentation of science, a misrepresentation of what we do, a complete mis-selling of the wonder of exploration, then we have a problem in our democracies. And it's the same problem that we have if we don't have an educated population, a population that is educated in STEM subjects, as Sir Peter emphasized. So for a democracy, a modern scientific democracy, to function correctly, then you need as many citizens as possible to at least have an understanding of the scientific method, if not the facts. You don't need to know the mass of the Higgs boson, but you need to know how we go about answering questions such as, how did the fundamental particles acquire mass in the universe? It's the scientific method that matters.
Apparently, Eric had been working on this for some time, but he wasn't able to finish it. This morning, as he left the building, he handed the program to Peter here and asked him to take a look at it. Peter did. He put a few things in that Eric seemed to be missing, and this is what came out.
Peter, is this your work?
Mostly Mr. Dale's.
But is this your draft?
Yes. Again, expanded on the original work by Mr. Dale, but yes.
What's your background?
My background?
Your CV?
I've been with the firm for 2.5 years working with Eric that whole time, but I hold a doctorate in engineering, specialty in propulsion from MIT with a bachelor's from Penn.
What is a specialty in propulsion, exactly?
My thesis was a study in the ways that friction ratios affect steering outcomes in aeronautical use under reduced gravity loads.
So you're a rocket scientist?
I was, yeah.
Interesting. How did you end up here?
Well, it's all just numbers, really. Just changing what you're adding up, and to speak freely, the money here is considerably more attractive.
Flower. At the same time, I see much more about the flower than he sees. I mean, it's not just beauty at this dimension, there's also beauty at a smaller dimension. I could imagine the cells in there, also the processes, the complicated actions inside, which also have a beauty. The fact that the colors and the flower evolved in order to attract insects to pollinate.